From the development of the turbine plane to the production of fast and sleek jets, throughout the early 20th century, the American military had effective use of advances in propulsion technology in its mission to achieve air superiority in World War I and World War II. In 1942, the United States Army Air Force created a change in aviation history by partnering with civilian aviation companies to create the first American military jet aircraft. The development to the deployment of the first American jet engine used in military service enabled the United States to maintain air superiority in the Korean War. Throughout the late 20th century and into the 21st century, jet engine aircraft dominated air warfare and led to the development of commercial aviation, supersonic, and spy aircraft, and the creation of faster and stronger jets. On December 17, 1903, in Kitty Hawk, North Carolina, Orville and Wilbur Wright successfully flew the first turbine engine-powered aircraft in American history that flew for 12 seconds and went 120 feet. The Wright brothers also introduced new technologies such as wind tunnel testing and helped progress and improve aeronautical engineering. Then later developments in World War I airplanes were just starting to be used for military applications. They were usually used for reconnaissance investigations against the enemy forces and prepare offensive or defensive actions. After many failures, aeronautical engineers gradually improved the design of turbine engines, leading to the planes such as the DH-4 Liberty, the only American-made aircraft to be flown in combat by American crews in World War I. Then into World War II, aircrafts included a shift in manufacturing of plane structures from wood and fabric to metal planes. Other improvements to the turbine engine planes included pressurized cabins, better engines, and changes to weaponry. World War II introduced a variety of new turbine engine planes, such as the famous Boeing B-29 bomber, P-51 Mustang, and the Douglas DC-3. World War II also brought the development of the first jet engine. Independently of one another, both the British and Germans developed turbojet engines during World War II. Although the British were the first to begin work on the jet engine, it was the Germans who flew the world's first jet aircraft. In 1939, German jet engine developer Dr. Hans von Ohain made the first flight-safe turbojet engine. In partnership with the German aircraft company Heinkel Aircraft, von Ohain's design led to the first flight of a jet engine-powered aircraft on August 27, 1939, the He-178. The Germans were also the first to send jet aircraft into combat with the Messerschmitt Me-262 on July 25, 1944, destroying a British photo reconnaissance Mosquito flying over Munich, Germany. However, due to the shortage of reliable jet engines, it was hard to produce jet engine aircrafts during the war. Independently and in parallel with the Germans, Air Commodore Sir Frank Whittle of the Royal Air Force invented and patented a jet engine in England as early as 1930, but did not have a working prototype until the British Gulfstream Meteor E-28/39 made its maiden voyage in 1941. Meanwhile, the British continued to make new jets using Whittle's designs and used Rolls-Royce to make a Nini engine, which they sold to the Soviet Union. Ultimately, this design helped power the famous Soviet fighter, the MiG-15, which became the challenger to the U.S. jet planes in the Korean War. One of the early flights of the British Gulfstream jet was observed by Major General Hap Arnold, Chief of the United States Army Air Force. After returning to the U.S., he guided the development of the first American jet. On October 1, 1942, the United States Army Air Force created a turning point in aviation history by partnering with Bell Aircraft to create the first American aircraft, the XP-59A Bell fighter aircraft, based on the GE's J-31 engine. Although the XP-59A had numerous design flaws that made it unsuitable as a fighter jet, the partnership between civilian aviation companies and the United States military in the development of jet engine technology laid the groundwork for future of American aerospace industry. And it was this partnership which allowed the U.S. military to explore jet engine development in many directions simultaneously.
The military was willing to tolerate failing. They knew going in that this multiple number of projects, only some of them were going to make it. Others were going to collapse. This is very much the idea that Silicon Valley venture capitalists have. You know, they will buy into 5, 8, 10 firms, and if 2 or 3 of them succeed, they make money. And if the other ones fail, life is hard. So this is the strategy that they undertook, a profusion strategy, many different kinds of projects, ultimately hoping that the best of them would surface and would become successful and give us real advantages.
This XP-59A flew at a speed of 409 miles per hour and reached an altitude of 35,000 feet. Unfortunately, it soon became obvious that the XP-59A was unsuitable for its intended role as a fighter. Air and Space Force magazine reported that in order to bring the aircraft out of a spin, the pilot had to deploy a drag chute. Furthermore, the controls had a tendency to freeze at high speeds, and pilots reported that rearward visibility from the cockpit was very poor. Happily, due to the USAAF's perfusion strategy of jet engine development, other American companies such as the Lockheed Martin Company were already working on solutions. One of the first American jets to see jet-to-jet air combat was the American F-80. However, the Russian competitor, the MiG-15, had the edge against the F-80 in speed and altitude. Because of the F-80's deficiencies, the American military created the F-86 to evenly match the MiG-15, even though the MiG-15 was faster and could go at higher altitudes. The frame of the MiG-15 aircraft could not handle hard bank turns or couldn't go higher altitudes because the windscreen would freeze over. In addition, better trained American pilots evened out the playing field between the US and Soviet air forces. Throughout the Korean War, the US military continued to develop faster and more efficient jet aircrafts, including the F-94, which was equipped with advanced radar systems and an afterburner. At the end of the Korean War, America's air superiority was clearly established over the Russian MiG-15 by an 8-to-1 kill ratio. Through the civilian military partnership, jet engines revolutionized and globalized the civilian air travel industry, turning previous journeys of weeks into journeys of hours. Through their power and durability, jet engine enabled aircraft manufacturers to build bigger, faster, and more productive airlines. Jet technologies also enabled airlines to reduce their operating costs and their airfares. Jet passenger service began in the United States in the late 1950s with the introduction of the Boeing 707 and Douglas DC-8 airlines. However, even as civilian aircraft embraced the jet engine, the U.S. military continued to make advances based on the same technology. The Douglas A-4 Skyhawk was one of the most important fighter aircrafts used in early Vietnam War by the U.S. Marines and Navy. This single-seat subsonic jet fighter and bomber entered service in 1956 and remained in production until 1979, and continued in military service with the U.S. Navy until 2003, serving as one of the primary aircrafts deployed during the Vietnam War. Throughout the Cold War, many improvements were needed for the jet aircraft to successfully combat and spy on Russia. Many of these technological developments were put into spy technology such as the U-2 and SR-71 Blackbird. The first U.S. spy aircraft in the Cold War was the U-2 in 1955. Created in secret by Kelly Johnson and the Lockheed Skunk Works, it reached a top speed of 410 miles per hour and a range of 7,000 miles. Another spy jet aircraft was the SR-71 Blackbird, and began development in 1956 and entered service in 1966. The Blackbird was used for reconnaissance missions and was able to monitor 96,000 square miles of land in 1 hour. More recently, the U.S. continued to maintain air superiority through the now famous F-16 fighter, which collectively flew more than 13,000 story strikes against Iraq during Operation Desert Storm in 1991, the most of any coalition aircraft. In conclusion, from the launch of the first military jet engine in 1941 to the adoption of the jet in civilian air travel, the jet engine has revolutionized both military warfare and civilian travel, creating a strong military-industrial partnership while connecting people and places across the globe in record time.